Hello students, yesterday I told you the 9 numericals of NEET 2020 and today I will take the question number from question number 10 to question number 18. 9 questions today. You watch the video completely and find and try to understand that how to find the right answer to the question. So you all subscribe, share and like the video, and also tell to your friends who are studying or they are trying to face the NEET exam 2021. So now I take the question number 9, 10. And 2, it is I think 1, 2, 3, 4, 5, 6, 7, 8, 10 to 70. So now I take question number 10. Now 10 question is a short electric dipole has a dipole moment of 16 into 10 raised to the power minus 9 coulomb meter. The electric potential due to the dipole potential due to the dipole at a point at distance 0.6 meter from the center of dipole. From the center of dipole situated on a line making an angle of 60 degrees. Making an angle of 60 degrees with the dipole axis. Dipole axis. Is now here you are given this 1/4 pi epsilon naught equal to 9 into 10 raised to the square per coulomb square. So now option 1 is 0. Option second is 50 volt. Option third is 200 volt. And option 4 is 400 volt. These are the choices. So, how to solve this? We know that this V is equal to 1 upon 4 pi epsilon naught P cos theta upon R square. This is the formula to find the electric potential at a distance R at the point which is situated at an angle theta. So this is given to be your 9 into 10 raised to the power 9. P is given to be your 16 into 10 raised to the power minus 9. And this is now cos 60 upon R square. R is given to be now 0.6. This is now 0.6 whole square. So this term will cancel. And this is your 9 into 16. Cos 60 is 1 by 2. And this is now your 0.6 into 0.6. So just you remove these points and you will find to be this to be 100 and this 2, this is now by 8, 6, so 3 by 2, 3, 3, this is now your 2 and 2 and 2, 4. This is not 2. So this will be 200 volt. So the electric potential because of the dipole at the angle theta is 200 volts. So right answer is, this is now third. So you just apply the formula and find the answer. And now question 11. A ball is thrown vertically downward. Thrown vertically downward. Vertically downward with a velocity of 20 meters per second. With a velocity of 20 meters per second from the top of a tower. From the top of a tower. It hits the ground. It hits the ground after some time with a velocity with a velocity 80 meters per second. The height of the tower is now here this given g equal to 10 meters per second square, and the options are: first is 300 meter. Second, 360 meter. Third, 340 meter. And now fifth is 320 meter. These are the options. You are given the initial velocity, final velocity, and you are given the acceleration. So this is a straight question. That ball is dropped from the height with the speed of so much, and then it hits the ground with the speed of so much, and you have to find the height of the tower. What is solution? This is now you use the equation b square equal to u square plus 2as. The third equation of motion. Now v is given to be 80. So this is now 80 square. U is given to be 20. This is now your 20 square plus 2. In place of a, you are given the value of g. This is now 10. S, the distance travelled, this is the height h of the tower. So this is now your 80 square minus 20 square equal to 20 h. So what problems comes that first the students square to this one, and then they square to this one, and then they subtract and then find the answer. So this becomes a tedious one. When we take in this way, then just you use the factor. Now if you factorize it, then this will be 80 plus 20 into 80 minus 20 equal to 20h. So this is now your 100, this is now 60, this is now 20, this is now h, 20, this is now y, 5. 5 into 60, therefore h equal to 300 meter. First option is the right one. So answer is first, the 300 meter. The height of the tower will be 300 meter. So you have not to think very much about this one. This is a straight question. This is not concerned with the projectile. Many of the students are thinking that this is the question from the projectile, so they apply the formula of projectile and then they find the answer. This becomes very tedious and very complicated. This is not the question of projectile. This is the straight question. Ball dropped from the height and hits the ground, and then find the height of the tower. So just to use the third equation of motion and just solve. And also here, when we are having these two square terms, they have to be subtracted. Then always use the factor. You have to use as small as possible, so that this could be solved in a very easy way. And now I am taking the question number 12. A resistance wire connected in left gap of a meter base. of a meter bridge. Balance is a 10 ohm resistance. Balance is a 10 ohm resistance in right gap at a point which divides the bridge wire in ratio 3:2. If the length of the resistance wire is resistance wire is 1.5 meter. The length of 1 ohm resistance resistance wire is, and the options are first 1.5 into 10 raised to the power minus 2 meter, second 1 into 10 raised to the power minus 2 meter, and third is 1.0 into 10 raised to the power minus 1 meter, and fourth is 1.5 minus 1 meter. So before going to this one, first let us make this is the gap, left gap, this is the right gap, and this is the wire. So this is now your A, and suppose this is the point B, this is D, C, and this is now point D. Now what is given to here? It is given that a resistance wire connected in the left gap of the meter bridge. Balance is a 10 ohm resistance in right gap. So in right gap you are given 10 ohm resistance. Here the resistance is not given to you. So this is generally we have P, Q, R and S. Here is some resistance. It balances and divides the wire in the ratio of 3:2. So this is given 3:2. So P is 3, Q is equal to 2. The length of 1 ohm resistance wire. If the length of resistance wire is 1.5, this resistance wire, its length is given to you 1.5 meter. So what if we have that initially we are not having the resistance, and the one resistance is given here, this is now 1 ohm. So let's apply the formula P upon Q equal to R upon S. Now P upon Q, this is now 3:2. 3 upon 2. R, this R you have to find. S is given to you 10 ohm. So this will cancel 5. So from here we are having R equal to 15 ohm. This means that the initial value of this resistance is 15 ohm and the length is 1.5. Now the resistance is 1 ohm, then what will be the length of this wire? What is the length of this wire? So now we will apply the formula that the resistance depends upon the length of the wire. तो हम इसमें क्या करें? Again, now R1 equal to 15 ohm, L1 equal to, your length is given 1.5 and now R2 equal to 1 ohm, then L2, this you have to find. This is given. तो क्या करें? पहले तो आप इसकी वैल्यू निकालना कि R की वैल्यू कितनी होती है, क्योंकि इनिशियल वैल्यू ये रेजिस्टेंस वायर की नहीं दे रखी है कितनी ओम है, सिर्फ ये दे रखा है कि ये जो 10 ओम रेजिस्टेंस है वो इसके राइट गैप के अंदर है। तो लेफ्ट गैप में कितना रेजिस्टेंस है ये आपको पहले पता करना पड़ेगा, उसके बाद ही आप ये पता कर पाएंगे कि इस रेजिस्टेंस के लिए लेंथ कितनी हो सकती है इसकी। So now we apply the simple formula R1 upon R2 equal to L1 upon L2. R1 is your 15, R2 is your 1, L1 1.5 and L2 you have to calculate. So this will be 15 will cancel, 0.1 is here, so L2 0.1 meter. But there is no answer like this one. So you have to write the answer 1.0 into 10 raised to the power minus 1. Okay, we have applied this 0, so this is no meaning to this one, so this is not so much meaning. The length of the wire will be 1.0 into 10 raised to the power minus 1. We have to match our answer with the given choices. This is all the choices are given in powers of 10. So you have to convert this in the power of 10. So the its option is you are given third answer is third. This is the right answer. So now I take the 13th question. 13th question. A uranium isotope, when a uranium isotope U-92-235 is bombarded with a neutron it generates krypton 3689 3 neutrons, and now you have to the answer. The choice is, first is your krypton 36 and 103. Second is barium 56. (56) 144. Third is your zirconium ZR, 36104. 36104. And now fourth option is krypton 36101. Krypton 36101. These are the options. You must know about the nuclear fission. When the uranium-92-235 is bombarded with the neutron, it splits in the krypton and barium, and with the emission of 3 neutrons plus the energy. So you know that if you just match the atomic number and atomic mass, so how this is now uranium 92-235 plus N01. It is now uranium 92-236. Then this goes to krypton 3689 plus 1N plus 3 N01. Like this. So what do you do? This is now given 0, this is now 36, this is now 92. So when we subtract, then we will get the 56 from this one. And also these are now 389, this is now 3, this is now 92 subtract from this one, and you will get 144. So this is what the barium, only the barium is given here. Barium 56 and 144. Always remember that when this uranium 92-235 is bombarded with the thermal neutron, there is the krypton and the barium, and then the emission of 3 fast neutrons plus the energy. So since only the barium is given here as the option, no other is like this one, so we have the right answer is barium. Answer is second, barium so much. And now question number 14. Question number 14. A long solenoid of 50 centimeter length having 100 turns carries a current of 2.5 ampere. The magnetic field at the center at the center center of the solenoid. Or this solenoid is, now there are options, and you are given mu naught equal to 4 pi into 10 raised to the power minus 7 Tesla meter per ampere. This is given to us. And now option is first 3.14 into 10 raised to the power minus 5 Tesla. Second is 6.28 into 10 raised to power minus 4 Tesla. And third is 3.14 into 10 raised to power minus 4 Tesla. And now fourth option is 6.28 into 10 raised to the power minus 5 Tesla. Minus 5 Tesla. So you are given the solenoid of length 50 centimeter. So we have the simple, you know about the solenoid, this B equal to mu naught Ni. This is your mu naught into Ni upon L, because N equal to N upon L. Number of turns per unit length, just you have the value 4 pi into 10 raised to the power minus 7 into N is given to you now 100, I 2.5, and length is 50 centimeter. 50 centimeter. So you convert this 50 centimeter into meter. This is now your 0.5. So now this point will cancel, and from this will be cancelled by 5 times. And now 5 into 4, this is now your 20 pi into 10 raised to the power minus 5. This 100, this is now 10 raised to the power minus 7. So much. And you know that the answer is given in terms of the value of pi, 3.14, 6.28, like this. So you have to change this answer according to these given options. So what will you do? आप इसको now B equal to 2 pi into 10 raised to the power minus 4. This is not 0, this is not so much, so 10 to the power minus 4, and 2 pi 3.14 into 10 raised to the power minus 4. So this is your 6.28 into 10 raised to the power minus 4. So much Tesla. And now choose this, so this is now your second option. 6.28 into 10 raised to the power minus 4. So we have to change our answer according to the given options. So this is the right answer. The second option is correct one. So just you apply the formula, but remember that how to do it. Now question number 15. Now question number 15. The average thermal energy of a monatomic gas is And now your options are given. You are given this kV is Boltzmann constant and T absolute temperature. This is given to you, and now option is first is that is your 7/2 kVt. Second is given to you 1/2 kV2, and third option is your 3/2 kVt, and now fourth option is 5/2 kVt. So this is the question from the equipartition law of energy, that for each degree of freedom the energy associated is 1/2 kT, and this is given the monatomic gas. This is to be keep in mind that for monatomic gas there are 3 degrees of freedom. For diatomic it is now 5, and for polyatomic it is 6. So being this monatomic gas, we have the degrees of freedom only 3. So the solution, this U is equal to 1/2 kVt into F. F the degree of freedom. So for monatomic, this energy E is equal to 1/2 kVt into 3. Here this F is equal to 3. This is not degree of freedom. So this is now your 3/2 kVt. So much. So right answer is third. Some questions become so easy that you can find the answer directly without applying of any kind of formula. For you are given this monatomic gas, degree of freedom is given 3. So for 1 degree of freedom, 1/2 kVt. So for 3, 3/2 kVt. Now question 16. A capillary tube of radius r is immersed in water. And water rises in it to a height of h. The mass of water in capillary capillary is 5 grams. 5 grams. Another capillary tube of radius 2r. Another capillary tube of radius 2r is immersed in water. The mass of the water that will rise that will rise in this tube is number 1, 20 gram. Second option 2.5 gram. Third option 5 gram. And fourth option 6 gram. This is the given options. So to solve this question, you must know the capillary action of this capillary tube. T equal to R H D G upon 2. And you find that how to find the mass of the water that rises in the tube. For that mass, we must know about the volume, because the density of the water is constant. So by calculating the volume, then you can find the mass. Or R into H equal to constant, because everything is constant here except R and H. So first you are given this R into H, this is now equal to 2R into H dash. For radius 2R, the height will be how much in this capillary tube? So this R and R will cancel and it will give you H dash equal to H upon 2. Now mass. M equal to volume into density. This question is based upon your understanding, because nothing is taught about this, that how much mass will be in the tube when this is immersed in the liquid. So this is based upon your knowledge that how to find this mass with the help of this formula. Since capillary tube is the cylindrical, so volume will be your pi r square h into density. This is now rho, this is now m. So what we have? This, just we have this m1. m1 upon m2 is equal to pi r square h into rho upon pi into this 2r whole square into h dash into rho. This is for the first case when the height goes h, and for second case when the height is h dash. So just you put these values and then you will find the answer. This pi and pi will cancel, rho and rho will cancel, and now we put the other values. So now this M1 initial value is 5 gram. M2 you have to find. This is now your R square H upon, this is now your 4 R square into H upon 2. 2R whole square. So this is now 4R square, and H dash, this is now H by 2. And then just you solve. This H and H will cancel, this 2 to this now, this so much, this 2, this so much. The 2 multiplied by 10. Therefore, M2 equal to 5 into 2 equal to 10 gram. Two R H dash, this is H by 2. This is now H dash, H by 2. There is option number 4. This is not 6. This is 10.0. So much. So the right option, the answer is your 4th. So if the radius of the tube is increased, then the mass in that tube will be more. So this is just, here it was the 5 gram, now this is now your 10 gram. So much water will rise in the tube. This is the question number 16. And now I take the question number 17. The ratio of contributions made by electric field and magnetic field components to the intensity of electromagnetic wave is. Now you are given the options. First option is 1 ratio c square. Second is c ratio 1. And third is 1 ratio 1. And now fourth is 1 ratio c. This is the question taken from the properties of the electromagnetic waves. If you have understood the properties, then this is given one of the property of electromagnetic waves, that the contributions of the electric field and magnetic field to the energy of the wave is equal. So contribution from the electric field and that of the magnetic field are equal. So this is the field energy. This electric energy is half epsilon naught E square, and also from the magnetic field this is half epsilon naught E square. So total energy is epsilon naught E square. It means that the contributions are equal from the electric field and the magnetic field. So the ratios are 1:1. Answer is your third. This is just a property of the electromagnetic wave. So I told you when I taught about the electromagnetic waves, then some questions are also asked from the properties of these waves. So you must learn them. You know that in every year one question is asked from the electromagnetic waves. So if you prepare the electromagnetic waves chapter to be very solid, then you can have one right answer to these questions. So in this way, you can find the answer with the help of the properties of electromagnetic waves. So you all like, share and subscribe the video. Thank you very much.